Today we are going to learn about phototransduction through a story. Once upon a time, there was a small land called Visiontopia. Visiontopia is ruled over by the mighty brain. It is occupied by three types of castles: the photoreceptor castle, the bipolar castle, and the ganglion castle. The job of these castles is to communicate with each other if the brain has a visitor or not, but only the ganglion castle is allowed to directly communicate with the brain. If someone wants to speak with the mighty brain, they must go through all three castles first. The first castle they must go through is the photoreceptor castle. As we can see, the photoreceptor castle is remained open, waiting for a visitor. Now we will talk about how things are run in the photoreceptor castle when there is not a visitor. One of the bridges that leads into the castle is remained open. This is the sodium bridge. With the sodium bridge open, sodium knights are free to come into the castle. For the gate to remain open, there must be a mighty CGMP bodyguard on duty. As long as there is enough CGMP bodyguards, the gate will remain open and the sodium knights continue to come into the castle. On the other side of the castle is the potassium bridge. The potassium bridge is always open because the potassium goblins that live in the castle are always free to leave and there is no bodyguard. Because the CGMP bodyguards are guarding the gate, the castle can remain open and is depolarized. This means the castle is excited. As mentioned earlier, the job of the castle is to communicate with each other and ultimately tell the mighty brain if there is a visitor. Because there is no visitor, the photoreceptor communicates to the other castles and puts on a glutamate fireworks show. The bipolar castle is closest to the photoreceptor castle and sees the glutamate fireworks first. The bipolar castle knows that this means there is no visitor and it doesn't need to do anything. As long as the bipolar castle remains silent, so does the ganglion castle, and no message is sent to the brain. Light is a courageous adventurer and is trying to meet the mighty brain that rules over all of the castles. It stumbles upon the photoreceptor castle and wonders if anyone inside could help it find the brain. Once it enters into the photoreceptor castle, it first goes to the rhodopsin check-in point. The G-protein tour guide is always working at this check-in. The G-protein tour guide knows what to do to help Light find the brain and starts the signaling that will lead to the brain. The G-protein tour guide goes and gets the phosphodiesterase horse, who is owned by the CGMP bodyguards. The PDE horse is then free to go over to its owner. When the bodyguard sees its horse, it knows it is on a break and transforms into just CMP. The bodyguard is now off duty and can leave the sodium bridge. With no CGMP bodyguard, the bridge is closed and sodium knights are not allowed to enter into the photoreceptor castle. However, the potassium goblins on the potassium bridge are always doing what they want and are still able to leave the castle. With no CGMP bodyguards, and goblins leaving the castle as they typically do, the photoreceptor signals to the other castle that it has a visitor by not having a glutamate fireworks show. Because there is no glutamate fireworks coming from the photoreceptor castle, the bipolar castle can now release its glutamate fireworks and lead Light in its direction. And because the bipolar castle sent off its glutamate fireworks, the ganglion castle releases its fireworks, leading Light towards it. And because the ganglion castle is in direct communication with the mighty brain, it points Light in the direction of it. Light is finally able to meet the mighty brain. I hope you were able to learn more about phototransduction in a creative way and the importance of communication in order for this process to take place.